Derivatives of trigonometric functions, part 2. Recall that the derivative of sine is cosine, the derivative of secant is secant tangent, and the derivative of tangent is secant squared. I recommend memorizing those three derivatives. The other three derivatives are very similar, except that the derivative of a is negative. So every time you're taking the derivative of a trigonometric function and it's something, then you know it's negative. Okay, let's use these rules to find a second derivative. We're going to find the second derivative of cosecant. Well, the first derivative of cosecant, I can just use my trig rule. Derivative of cosecant is negative cosecant cotangent. So I write that down. Derivative of cosecant is negative cosecant cotangent. Now I need to find the second derivative. The second derivative means I have to take the derivative of this product. It's a product, so I have to use the product rule. Derivative of a product is the derivative of the first times the second plus the first times the derivative of the second. I see that I'm going to have to remind myself of what the derivative of cosecant is and what the derivative of cotangent is. Well, the derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. So we put this information into our work. So the derivative of cosecant is negative cosecant cotangent. The derivative of cotangent is negative cosecant squared. The rest is just cleanup. I have double negatives for the first term and double negatives for the second term. So my first term, when it cleans up, I'm left with cosecant times cotangent squared. And my second term, I've got two negatives again, and so I'm left with cosecant to the third of x. You can pull out the cosecant x if you want to. For me, on a test, either the last answer or the second to the last answer would be fine. I'd like to go back to talking about a couple of these limits that we talked about in part 1. We talked about them very briefly. These are special limits that were used for finding the derivative of sine and the derivative of cosine. So what I'd like to do is just let's use these limits, or let's use this one limit, sine x over x. Let's use that to find a limit. So notice that I have sine x in the numerator and x in the denominator. So the angle of sine, the angle is going to 0, and the denominator is going to 0. So what if I ask you, what's the limit as t goes to 0, not of sine t over t, but sine of 4t over t? Well, here's the problem. 4t does not go to 0 as fast as the denominator t. So my angle is not going to 0 at the same rate that my denominator is. But I can fix that. I'm going to multiply the numerator and the denominator by 4. And then I'm going to pull out one of the 4's. Now look at my angle and my denominator. My angle is 4t, and my denominator is 4t. So my angle and my denominator are going to 0 at the same rate. And so sine of 4t over 4t, as t goes to 0, is equal to 1. And the overall limit is 4 times 1, or 4. And that concludes part 2 of derivatives of trigonometric functions. I'll see you in the next section. Take care.